Alright, so hopefully you've had a chance now to practice your one-step equations. And you've got those down and you remember your sign number rules because you know that's going to be pretty important there. Next we're going to move on to two-step equations. And for two-step equations, we actually are going to work in reverse order of operations. So that means we'll be usually undoing the addition or subtraction first, then the multiplication or division. Lots of times undoing the multiplication. And there are some times that we have to undo division first if the entire one side, like if there is more than one term in the fraction. So you'll see what we mean. So kind of a basic example. 13 is equal to 3x plus 1. So to solve this, we'll subtract the 1 first. So we're undoing the addition. Whatever we do to one side, we're doing to the other side. So now I have 12 is equal to 3x. And then now, to get rid of the 3, we'll divide by 3. So then 4 is equal to x. And remember I said we could always check a solution by plugging the number in. So if we replace this x with a 4, 13 is equal to 3 times 4 plus 1. 12 plus 1. Indeed, 12 plus 1 is 13. Check. So that's the check. So again, it doesn't matter if your x is on the left or the right. Your goal is to get it by itself. Another reason to think of getting rid of that 1 first is because the 1 is a constant. So it wants to be over there on the other side of the equation with the other constant. Get rid of the check just to give us a little extra space. So another type of problem we might see might be x over 5 minus 2 is equal to 9. So sometimes people like, there's a fraction, oh no. It's not as bad as it might look. Again, in this case, that fraction is just with the x. So I can go ahead and add 2 first. Then I have x over 5. These would cancel out. Is 11. And then remember, when we have a one-step equation that's division, to solve it, we multiply. So times 5 on both sides. That makes this just x, and 11 times 5 is 55. So 55 divided by 5, take away 2, should equal 9. 55 divided by 5, 11. 11 take away 2, it is 9. Check, check. It works. So to check it, we plug it in, plug it in. So we're plugging it in. Plugging in our answer for the variable. Now, another type of problem that you might see with a fraction in it is if instead I had this. And these two problems are not the same, because these two problems, one of them, only the x is getting divided by 5. This one, the whole thing is getting divided by 5. So to get rid of this 5, I would have to multiply first. I can't add 2 because it's not really 2, it's really like 2/5. So I would need to multiply first if this whole thing is in a fraction. Then I would have x minus 2 is equal to 45. Remember, we're doing the same thing on both sides. Then add 2 to both sides. So here, x would be equal to 47. And if I tested it, checked it, 47, take away 2 is 45, and 45 divided by 5 is 9. So next we're going to work on IXL J4. So remember, your assignments are on IXL.com. If you have not received your login, please contact me to get that. So I'm going to switch over there so we can do a few problems from that lesson. Everybody's problems are different, so it's not like you're going to have the exact same problems, but so you have some more examples. Just a reminder that in IXL, we are, unless I tell you otherwise, the lessons, when I give them to you, we are working in the, it's of course math, and in the Algebra 1 tab. So there are things on IXL from preschool through calculus. We're going to be working on Algebra 1. So when I just say J4, I mean in the Algebra 1 and then J and Lesson 4. Also, I will have recommended things to you, so you will see that the skills have been recommended or suggested. So for this one, we're using S is our variable that we're trying to find. And I have 8 plus 3s is equal to 11. So first we're going to get that 8, that constant, over to the right side with the other constant. So I need to subtract 8, because that's how I'm going to get rid of it here, so that that s is getting closer to being by itself. And then 11 minus 8 is 3. Then divide both sides by 3. And s is equal to 1. And whenever you have your answer, remember, even if it's just mentally, you can check it by plugging it in. 3 times 1, so 8 plus 3 does equal 11. So then I know that it works. So this one is written very much the same way. We would subtract 9 on both sides. 15 minus 9 is 6. Divide by 2 is 3. Now we have one with a fraction. Sorry for that delay. And we can still get rid of our adding and subtracting first. There are actually 2 ways to do a problem like this. Remember, the ones that have one big fraction, you don't have a choice. But here I actually do have a choice. I can add 1 first. And then multiply by 2. Now, because it's not a, even though it's not a big fraction, I could choose to multiply first. But if I do, that multiplying would happen here, and it would be happening to both of these. I would have to distribute. So this would become 4, and I think of it like the Oprah method. You get a 2, and you get a 2, and you get a 2 also, because it's being distributed on the right side. So this one would cancel, but there would still be a 2 times this 1. So I could get rid of the fraction first, but I would have to multiply every part, even that -1. Then undo the subtraction. Notice I still get the same answer. If I go if I would forget to multiply the 1, then I would have gotten 5 for an answer. If I tried to put 5 back in the equation, 5 divided by 2 would be 2.5. And 2.5 subtract 1 would not be 2. But 6 divided by 2 is 3, and 3 subtract 1 is 2. So 6 is our correct answer. Gonna see what happens, how much things change here. So once we get a little higher, we start throwing in more negative numbers, and we haven't practiced much with those for these, so I want to be sure to give you at least an example like that. Again, this is one you could get rid of the fraction first. It would make for some big numbers in the middle. So while this says add, think about what you're adding to the b. You're adding a negative. You want to get rid of that -48. So we're going to add a +48. So keep in mind that adding a negative in the equation to start with is the same thing as if it said subtract. So to 0 pair this out, I'd have to do +48. So I need to do +48 over here. The b over -5 is just waiting to be gotten rid of. And then -52 and +48, opposite signs, subtract, bigger number wins. So that's a -4. Then to get rid of this fraction, to get rid of the division, we use the inverse operation, which means we're going to multiply by -5. Remember, in multiplying and dividing, you want to use the exact same number, not the opposite sign. And then so times -5 over here. So then b is equal to +20. And if I make something go away too fast, remember you can rewind. Lots of scrolling when I make it this big. So this one, the next problem looks really short. Wait for the iPad to catch up that I've changed problems. Maybe. So -k. Remember that a negative variable is like it has a -1 as its coefficient. It's like -1 times k, or the opposite of k. So it may help to slide a 1 in there to think about it that way. Then I'm going to get rid of this negative 1. Remember, I know it says plus, but because it says plus a negative, to cancel that out or to zero pair it out, I would have to add a positive 1. Same thing on the other side, always doing the same thing to both sides of the equation. So then negative 1k is equal to the opposite sign, so negative 2. Had to subtract, bigger number was negative. And then now to get the k by itself, I'm dividing by negative 1. Or you could think if the opposite of k is negative 2, k must be positive 2. So k is 2. If I plug 2 in, notice that this has a negative sign up there, so it would be minus, then replace the k with a 2. And I think we can agree that that's true, that when I write that, it would become negative 2 plus negative 1 equals negative 3. So I hope those examples are helpful. Please reach out if you have questions. Please try to get to 80 as a SMART score.